So this will be our second example of a one proportion confidence interval. Before we begin though, I want to talk about this example. This is a little bit more personal. It's based in Maryland and has to do with lead poisoning. The lead poisoning found in Baltimore City tends to be mainly from paint, that is lead-based paint that is flaked off walls. But there's something to be drawn out of this, and that is, I want you to go ahead, pause the video, and I want you to look up Flint, Michigan and their water crisis. This is something that came out in 2014. The state of emergency was declared in 2016, and the response was neither swift nor very effective. Now, this is an excellent example of structural racism and class discrimination, and so it's really something to check out, and it's relevant to the example we're going to be talking about today. Okay, now back on point, once again, a one proportion confidence interval, and I can tell that because as I look through it, first of all, it's telling me I want to do a confidence interval. I also see I only have one sample. Now, the problem here comes with determining this is proportion. Now, as you read through this, we see that we found that out of. When we say out of, we're talking about, well, there is a sample, and then out of that sample, this proportion or percentage had a certain characteristic. And so it's that's keying us in that we want to be doing a proportion problem here. If I've got a one proportion confidence interval, I need to list p hat, I need to list n, and I need to list z. Z 1.96, once again, because we are a 95% confidence interval. And in this case, well, you got to be careful here. There are two numbers, this one right here and that one right there. N should be our overall sample size, and so that is out of the 16,892 children. P hat then would be the percentage who have the characteristic we're looking at, that is, had blood levels of 5 micrograms per deciliter or higher. So P hat is going to be the 971 out of 6892. When you find this decimal here, remember that we always keep 4 decimal places for it, and so here we're going to have 0.0575 on it. This is telling us that out of about the 16,000 kids tested in Baltimore City in 2016, about 5.75% had blood lead levels that were elevated. Now, once again, our goal is to generalize to all kids in Baltimore City, and so going to step 2, we need our calculation, and the only calculation we need is SE. SE, square root, p hat, 1 minus p hat, all over n. When we plug this in then, 0.0575, 1 minus 0.0575, all over 16892. Once again, if you are sketchy with calculators, make sure you simplify that subtraction before you actually plug it in. Plugging this in, I believe you should get right around 0.0018. That is actually super interesting. It is small. In fact, it is tiny. It's important to notice that our SE we got here was a lot smaller than the SE we got before, and the reason behind that is actually our sample size. The bigger the sample size, the less error we're going to have when we go to generalize to our population. Now, that has to do with sampling distributions, which we talked about before. Based on my SE and the other information I have here, I can go to step 3, which is p hat plus or minus z times SE. That'll be 0.0575 plus or minus 1.96 times 0.0018. And plugging that in, my lower value is going to be 0.054 and upper 0.061, once again keeping 4 decimal places on there. Final step, or final thing I do with each confidence interval is to go ahead and state. So when I state this, we are 95% confident, and I know I'm 95% confident because I used a z-score of 1.96, and because the problem told me. We are 95% confident that the true percent, I say this because I'm dealing with percentages, of all kids in Baltimore City who have elevated blood lead levels is between 5.4% and 6.1%. And so what we've concluded here once again is that based on these 16,000 kids that were actually tested, and we're assuming that those 16,000 kids are a random selection, that is, that they're representative of kids in general in Baltimore City, then we estimate that somewhere between 5.4 and 6.1% of all kids in Baltimore City that actually have elevated blood lead levels. Now, a quick disclaimer about this, and that is there's consistently this debate over what is counted as a elevated blood level, as well as what's counted as high lead content in different water sources. It's something interesting to look up and check about, well, how is it measured in different communities, and how do people speak about it in different communities, or different ethnic or racial groups, or different class levels. So, your statistics are one portion confidence interval here, and something to think about.